Welcome to the first session of the certificate course of Artificial Intelligence in Medicine, Module 1. And this, of course, is going to be a laid back session, but with a lot of information. And today's module will go a little extended, a little beyond 1 hour. So I hope you all are okay with that. We'll try to capsulate a lot of information in a shorter period of time. For some of you who are completely new to artificial intelligence and the concepts and the terminologies, you might find a little bit perplexed in the very beginning to get yourself accustomed to these terms, but do not worry, it's just a start, and these terms are going to be repeatedly discussed throughout the entire 3.5 months course that you will be taking. For some of you who are already familiar with what AI is and is already in certain level of your AI journey, will probably find it interesting to look at the evolution with the fundamental concepts and exploring into the history of AI with its focus on the role in healthcare. So on this note, let's start the first session for the day. So before we start discussing about artificial intelligence, today we will be looking at what do we mean by intelligence. Now, the definition in textbooks published earlier days is intelligence means to perceive, to analyze, and react. So it is the group of abilities like to understand, to learn, to reason, to make a decision, and to solve a problem. This is how the human mind has evolved as an intelligent being. And today we are training computers and machine ecosystem to do the same, to perceive, to analyze, and to react to a certain circumstances. And that is artificial intelligence as a branch of computer science. If we have to understand artificial intelligence, we have to understand intelligence as a subject, as a context. The ability to calculate, to reason, to perceive relationships, analogies, learn from experiences, store and retrieve information from the memory, solve problems, comprehend complex ideas, use natural language fluently, classify, generalize, and adapt to new iterations or new circumstances and situations. I think that is what human intelligence had been all about. Now, Howard Gardner was an American psychologist who defined intelligence in multifold ways. For example, linguistic intelligence, the ability to speak, recognize, and use the mechanisms of phonology. Likewise, musical intelligence, logical and mathematical intelligence. Spatial intelligence is a very, very important intelligence that the human beings possess. And again, when you look at the AI ecosystem, this is an intelligence that intertwines when we look at robotics coming into existence. Bodily and kinesthetic intelligence, interpersonal intelligence, and intrapersonal intelligence, something which emulates the human to human connect, the human to the inner connect. So these were the different ways in which we can define intelligence. Now, when you try to create this intelligence in an artificial way, in an artificial world, you will make sure that each of these ingredients of intelligence is there in that artificial ecosystem. So what are the components of intelligence and what are the primary endpoints which defines intelligence? Of course, the first and the foremost thing is the ability to communicate. So linguistic intelligence is the most important segment. Linguistic intelligence, with the help of the technologies, is helping us to communicate with the AI ecosystem so fluently. Reasoning, learning, problem-solving capabilities, and perceptions are the various components of intelligence. Now let's explore and look at each of them. Now, what is reasoning? Reasoning, by the definition, means a set of processes that enables us to provide a basis for judgment, making decisions and predictions. Now, this is how the human mind reasons, either as inductive reasoning or as deductive reasoning. So inductive reasoning, it conducts specific observations to make a broader general statement. Deductive reasoning it starts with a general statement, examines the possibility to reach a specific or a logical conclusion. Let's try to look at it from the example of healthcare. So for example, inductive reasoning in a healthcare using artificial intelligence will be an AI system that analyzes specific health data. For example, data sets of patients with high cholesterols and cardiovascular events to infer a broader pattern, such as identifying that patients with certain cholesterol levels are at a higher risk of heart disease. So finding a positive correlation by inducing certain data points to reach a broader pattern is called inductive reasoning. And this is exactly how machine learning models work for predictive analytics, for example, in population health. Now, what could be an example of deductive reasoning? Deductive reasoning means an AI model has already been programmed with a generalized rule, and it's going to deduct its conclusion based on that rule. So for example, if the blood glucose level exceeds 180 milligram per deciliter after meals, then the patient has postprandial hyperglycemia. So that is a training which you have already given to the model. Applying this rule, the AI ecosystem is going to detect the condition in the individual patients whose test results match the criteria. This has been the fundamental of the primitive, not so primitive, but the primitive and conventional AI, which is the rule-based expert system. You teach it a rule, it follows the rule and deduces a reasoning. And again, as I say, when we talk about intelligence in the entire AI ecosystem, it is either inductive reasoning, it is either deductive reasoning. And in most of the reasoning models that we now see, you will see these two fundamental patterns of reasoning working. Again, another segment of intelligence is learning, the activity of gaining knowledge or skill by studying, practicing, being taught, or experiencing something. This is what we all do as humans. This is what we are teaching artificial intelligence ecosystems to do. And this is very, very important because it enhances the awareness of the subjects of the study. And that is what AI is getting. Now, again, what are the different types of learning? Learning by hearing, by analyzing auditory data, that is auditory learning. Episodic learning means it learns by remembering sequence of events or data. If you always try to, kind of look at the way human beings learn, it's always so similar the way AI is being trained to learn. But sometimes we know that AI can learn in different ways beyond what the human brains could learn. Motor learning, AI system learns precise movements for the task execution. An example could be the surgical robots. Observational learning, this is something, again, as humans, we imbibe this art of observational learning, learning by observing and imitating patterns, looking and analyzing certain patterns and mapping it in our brain, and then reacting to it when a similar situation happens. So these are the different types of learning which exists. Perceptual learning. When AI learns to recognize and classify previously encountered stimuli, and this is why we say you give it an example when you're prompting, and you give it a case study. So if a similar kind of situation happens, it's going to be able to find it out. Now, commonest application is AI-enabled systems identifying tumors in the medical imaging by learning from labeled data sets of X-rays or MRIs. In other words, we call it supervised machine learning, which these are all the terms which today, some of you, as I said, are starting for the first time, might find it a little difficult to imbibe, but as it goes along the journey, you will find yourselves very familiar with these terms. Likewise, there is relational learning, where the AI differentiates amongst the stimuli based on relationship properties rather than absolutes. There is spatial learning, where the AI learns by interpreting visual or spatial data. And stimulus response learning means it responds to a specific stimuli. So what could be the typical example? A wearable device sending alerts when they detect a drop in the oxygen saturation level, prompting an immediate medical attention. So see, these are the different ways you can teach an AI ecosystem to learn and respond to a certain circumstances. Now, eventually, the whole fulcrum and the purpose of using an intelligent ecosystem is to solve a problem, is to make the lives easier of a human being. Machines were invented to make the job and lives easier of human beings, and that's why we are also building AI ecosystem. Problem solving means decision making, which is the process of selecting the best suitable alternative out of multiple alternatives to reach the desired goals which are available. And this is one of the most important, crucial role that an AI should play. It should solve a problem and it should help us take complex decision making in a structured and a simplified manner. Now, perception is very, very important. Now, this is a very important segment of intelligence. For humans, perception is aided by the sensory organs. In the domain of AI, perception mechanisms put the data acquired by these sensors together in a meaningful manner. One commonest example of perception is computer vision. Computer vision is something which is existing even in your Google Photos and so many other tools across the day-to-day use that we use in our mobile phones, etc., which can analyze visual data, pick up pattern. And that is nothing but fundamental AI, which is computer vision. And computer vision is built with the concept of perceptive intelligence or perception segment of the intelligence. Linguistic intelligence is, again, which is very, very important. The ability to use, comprehend, speak, and write the verbal and written language. A powerful segment of the intelligence that makes us communicate with the AI ecosystem and vice versa so fluently. Chatbots are one of the typical examples of linguistic intelligence which is given to the AI ecosystem. So let's quickly look at human versus machine intelligence. Humans perceive pattern. Machines also perceive by pattern, by set rules of data. And humans can figure out complete object even if some parts are missing or distorted. Well, AI, machine can do it. Earlier, maybe we could say that they cannot do it, but maybe with the development of robotics and AI intertwining into each other, then it will be able to even figure out objects correctly once some part of it is missing or distorted. And finally, another important segment of intelligence is cognitive intelligence. And this is a segment which also overlaps learning and something which is very important, knowledge. And cognition and learning intertwines and makes us a wiser individual with the knowledge that we have. This is a continuum from understanding to thinking and then learning and then re-understanding and again reasoning and thinking. And continuously it becomes an intelligence decision going forward. This continuum is called the data to intelligent continuum. So from data to information, from information to knowledge, from knowledge to understanding, and from understanding to wisdom. That is the data to intelligence continuum that we are looking at. Human brain has been trained to understand, look at numbers, look at data, look at points, understand a pattern, grasp the reason out of it, imbibe it with the principles, and then take a wiser decision. And this data to intelligence continuum is what the AI ecosystem is trained to learn. So data to information, to knowledge, to intelligence, and then finally to wisdom. Okay, so since this is a lecture and it's a session, we keep it as interactive as possible with you all. So let me see if I can get some polls going, okay? So let's see if you guys can take the first poll. Now there's a poll option that should come up right on your screen. The polls are active. Could you all see this? Admin team, can you confirm me? Yes, I can see some responses coming in already. Okay, great. So which of the following best defines artificial intelligence? Simulation of human intelligence in machines through learning and problem solving. I think all of you have got that correct. Most of you are voting. So we got 24 votes. So do poll in. And there's a second question that we will also do. Let's have everybody else polling in as well. A type of machine that can only process numerical data. Well, not necessarily. The whole power of AI is through learning and problem-solving capabilities, and that defines intelligence, dear friends. Wonderful. Let's try and do the second poll. Now, this is going to get interesting. What do you mean by what type of reasoning is applied when an AI model generalizes the conclusion based on specific data? Is it deductive reasoning? Is it inductive reasoning? Is it analogical reasoning? Is it abductive reasoning? All right, let's see. Okay. I still see the house going with inductive reasoning. And of course, deductive reasoning as well. So when an AI model generalizes a conclusion based on specific patient data, a broad spectrum outcome based on a certain pattern, what type of reasoning is that? We gave you the example of cholesterol levels and prediction of a generalized condition like prevalence of heart disease. And the other example we gave you was, if the patient has a blood sugar of this, then classify this as postprandial hyperglycemia. So which one is inductive and which one is reasoning? So when the AI model can generalize a conclusion based on specific data points, it is called inductive reasoning. When it's the other way around, it's called deductive reasoning. So great. We can get about 35, 33 votes. I hope the numbers increase as we go on. So that was a quick exercise. Yep, you can all see the results now. I will also see if I can show the results to everyone. Yep. So the first one, we all got the results. The second one also, we got the results. Okay, just quickly, let me see how many people are still in. Okay, we have 50 people in. So I think we can get more votes in the upcoming, ongoing live polls. Okay, so we spoke about data to intelligence continuum. Now we look at human-machine intelligence continuum. And of course, it includes assisted intelligence, augmented intelligence, and autonomous intelligence. Assisted intelligence and augmented intelligence these days are often terms which are also used in parallel to artificial intelligence. Autonomous intelligence is exemplified by the autonomous driven vehicle, involves an automated decision-making capability of the machine. In today's world, we are looking at agents and agentic AI solutions perform autonomous tasks. A quick look at the differences between assisted, augmented, and autonomous intelligence, and the various examples that can be there in the field of healthcare. Some reading materials will all be provided to you all, so we may not go through each of the slides in details, but of course, as you go through them, you will get familiar with the terms as you go along. Now, I'm sure you all have heard about this Turing test. In 1950, Alan Turing, in his paper Computing Machinery and Intelligence, proposed a gaming setup in which a machine and a human is placed in a separate room. A third participant, who is the interrogator, communicates with both through the textual interface. This is a very primitive way to identify whether it's machine or human. Now, if the interrogator cannot reliably distinguish the machine from the human, then the machine is considered artificially intelligent. But when generative AI came into existence, the entire test of Turing test became a failure because it no longer holds true, because it can generate new content. But for evaluating the primitive intelligent tools, Turing test was very, very useful test. And this is now a historical test, but just a matter of thing for us to know. But it is something on which the evolution of artificial intelligence has happened. Now, if you look at the history of artificial intelligence, some of you would say that did it start in 1950 by Alan Turing? Well, look at this. It's AI, if you can really define it as an intelligence beyond human intelligence, somewhere in the ecosystem, in the environment, artificially there, then it starts right from 400 BC. And you can see the history right here on the screen. Everything in mathematics is also a form of intelligence, somewhere in terms of reasoning and perception. And of course, the Turing test, the Turing machine was proposed by, was Alan Turing in 1936. And the Turing test was first performed in 1950. The term artificial intelligence was coined by John McCarthy in the year 1956 in the Dartmouth conference. And that's where we started knowing about this term. And then you had GPS, General Problem Solver, in 1957. And this list continues. And you can see the entire, entire wave of AI being developed. Neural networks came into the year of 1970s and 1980s. And GANs, Generative Adversarial Network, this is going to be a very interesting term to understand for us, especially in the field of healthcare, was first developed in 2014. And this was a big development in the year 2015 when DeepMind's AlphaGo defeated the human Go champions, which showcased that machines can defeat humans through advanced deep learning models. Finally, in the year 2018 and 17 onwards, we started getting the generative pre-trained transformer model coming in. And that's where you see the GPTs, the BERT, and the GPT-3 come in. And finally, in 2022, we all know what happened. Generative AI was made open to the public, and the huge hype of AI in the entire human ecosystem became a big buzzword or a bubble, as we all say. 2024 and 2025 saw the rise of AI agents and agentic AI. Today, we are all talking about agentic solutions, which can function autonomously in healthcare. So what are the emerging trends? Multimodal AI, agentic system, AI in healthcare, and quantum AI. We'll have a module on quantum AI, which will also give you an understanding of what the future holds. And governance is very important. So these are the emerging trends happening in today's world. We're talking about multimodal AI, agentic AI. There's a lot of discussions, just like this course, happening around responsible AI in healthcare. Now, we introduced some terms, and let's try to look at the basic fundamental of some of these terms. I had repeatedly said that something called agents came into existence. So by the definition of an agent, it is anything that can perceive its environment through a sensor and act upon that environment through effectors. This is important because when you look at robots, this is exactly the way they function. That's called a robotic agent. We as humans, we have sensory organs like the eyes, the ears, the nose, the tongue, and the effector organs are our hands, legs, mouth for effectors. A software agent has encoded bit strings as its programs and actions. So again, the AI ecosystem runs on agents. In this case, the software agent. It can sometimes work together with the robotic agent when AI and robotics come together. Now, there are various types of agents. For example, a simple reflex agent, a model-based reflex agent, a goal-based reflex agent, or a utility-based agent. These agents are defined based on how the agent is interacting with the environment through the sensor and the effector. So a simple reflex agent responds to predefined conditions. A goal-based agent will use internal models to make decisions. A model-based agent will act to achieve specific objectives. So if it is based on a certain model, it is going to act to achieve specific objectives in the environment in which it is put. So it's like a condition-based model. And finally, utility-based agents. they will optimize the decision based on utility function. Now, these are very primitive way of defining agents, and why this is important for us to know in the context of understanding the fundamentals of healthcare is when you're looking at working with agents, somewhere the development of these agents have come through the evolution of these simple agents, the goal-based agents, model-based agents, or maybe reflex-based, utility-based agents. Likewise, where we have agents, we have environment. And there could be various types of environment on which these agents are working on. They can work on discrete or continuous environment. The environment could be observable or partially observable. The environment could be a static environment or a dynamic environment. A static environment, for example, a situation where you're only interpreting the lab results. A dynamic environment which is rapidly evolving, for example, with real-time adjustment, for example, in the critical care, managing shock or sepsis. Now, the environment could be interacting with a single agent or with a multiple agents, right? So if it's connected through multiple ecosystem, then it could be a multiple agent. The environment can be accessible or inaccessible. Accessible environment could be like an EMR system with comprehensive patient histories. Inaccessible is where the data is fragmented or unavailable, right? Deterministic or non-deterministic kind of environment. So deterministic environment is where the predictable outcome is based on the known data and treatments. For example, administering insulin for hypoglycemia. Non-deterministic is when you're using an agent and an environment to respond to an experimental treatment, for example, where the outcomes are uncertain, you don't know how it is going to be. The environment could be episodic, it could be non-episodic. Episodic, like case handled at one time without dependency on past events. For example, prescribing antibiotics for an infection. Non-episodic environments could be long-term care involving cumulative decisions like managing diabetes or hypertension over a period of years. Again, these examples of understanding agents and environment is to let us know that in the medical ecosystem, in the healthcare ecosystem, there will be similar kind of examples and nuances where one variable will act as an environment. It could be your electronic health record, it could be your labs in the hospital, it could be your HIMS, and one agent will be connected to it, which is going to interact with the environment through sensors and effectors to give you certain outputs. And these forms the fundamentals of artificial intelligence ecosystem. So moving on to the next section, what are the goals of artificial intelligence? The first goal is to emulate human intelligence. So when we look at AI and we say that can AI get more intelligent or as intelligent as human? Of course it can, because by the fundamental goal of it, it should emulate human intelligence. It should understand human cognition and it should simulate human-like reasoning. The more it does, the more it syncs with your thinking and intelligent reasoning, the better it gets. The purpose of AI, the goal of AI, is to have problem-solving capabilities, and this is the most important goal. So a very important point for all of us to take back, whenever we are looking at artificial intelligence beyond the hype, beyond the bubble, we must answer this question: is it really solving a problem? Is it really answering a need gap? Well, if it is not doing so, then it is not the AI that is there, that is right for me. One of the goals of AI is to create autonomous system. As we are now evolving from artificial narrow intelligence to artificial general intelligence, we are going to look at more and more autonomous functioning. And of course, AI should make itself more intelligent, so understanding intelligence or cognitive modeling. The roots of artificial intelligence, just like the roots of human intelligence, will be based on philosophy, logic and mathematics playing a very, very important part. Computation is going to be a bigger segment. Psychology and cognitive science, biology and neuroscience, and evolution. As we have seen human beings evolve, we are going to see artificial intelligence evolve, and that's already happening. What AI we were using in the year 2022, you are using a much evolved versions of artificial intelligence today in the year 2026. And this adaptation and learning is happening possibly at a much faster rate than the human intelligence evolution was happening. And finally, we are going to look at something called artificial consciousness, the creation of machine intelligence that can rival human cognitive abilities. It will have computer science, it will have neurophysiology, it will have philosophy in the reasoning there. The mere discussion of artificial consciousness reflects the human aspirations as well as the human fear regarding the future of AI. I think a big chunk of discussion in the human mind is around this. Are we creating something that can be bigger and more intelligent than us? But let's come back to what we have now. The subfields of artificial intelligence. Speech processing, very important. And as I say, this is the most important segment of AI that makes it so very useful to us. Natural language processing is also equally important. Planning, again, to solve a specific problem Engineering and expert system is one of the conventional segment of artificial intelligence. Fuzzy system and fuzzy logic. We'll explain this in the upcoming slides. What do we mean by fuzzy systems? And models of brain evolution, brain modeling or evolutionary model, like the neural network or the genetic algorithms, which was some of the primitive models, which was there in the earlier days of machine learning. Now, what are the types of artificial intelligence? Machine learning, machine intelligence, and machine consciousness. Today, we are somewhere in between artificial narrow intelligence and probably heading a bit into artificial general intelligence. As we speak, we are looking at an AI ecosystem, learning, reasoning, perceiving, and with linguistic intelligence and everything, the different formats which I just told you, and gradually improving its own performance towards more general intelligence, more broader intelligence. And eventually, possibly, we are looking at a day where we're looking at artificial superintelligence, which is artificial consciousness or machine consciousness, as we call it. Another way of classifying artificial intelligence, reactive or proactive. Now, today's world, majority of the AI which we are using is predominantly reactive artificial intelligence. A reactive AI would be a simple classification, a pattern recognition task, following certain rules. Most of the generative AI tools which we're using performs in a reactive manner. But when you are gradually going into proactive artificial intelligence, where it automates and performs autonomously a lot of tasks, it can start becoming self-aware. So there is reactive AI at one side, there is proactive AI at the other side, using agents and agentic solution. And this is the year where we are kind of looking where there is reactive AI and where there's proactive AI, and we are probably shifting, and we have to use it very, very wisely, very, very carefully and responsibly in the field of healthcare when we talk about it. Okay, so much for the theory. Let's get back to our polls. I hope we'll be getting more results and more polls coming in. So I'm going to start the third poll now. Okay, so here it goes on your screen. I hope you're all getting it. Which milestone marked the formal birth of AI as a field of study? It's a bit of a history question. We never do history in AI classes. This is the only class where we'll do history, so bear with me. 1936, 1950, 1956, or 1946? Right. So Alan Turing was the person who introduced the term, who did the Turing test. Okay, I'm still seeing more votes coming in. Now, I will show you the results in a bit, but I'm looking for more votes coming in. I have 35 votes in. I'm expecting more people to vote. I hope you're not sleeping. I think we have more than 50 people in now, so need more votes. Okay, so most of you feel it's the Turing test. Well, all right, let's give you the results. You can all see the results now. Most of you feel it's the Turing test, but the formal birth of AI as a field of study was during the Dartmouth conference in 1956, where John McCarthy coined the term artificial intelligence. So that's where AI came into existence. But of course, each of the others are equally important milestones. Great. History is something which keeps on teaching us, so we must not forget the history, no matter how much we look into the future. Nice. Let's get on with the next poll. Now, this is going to be interesting if you have understood a little bit about the agents which I told you. It's not something that we really need to understand in depth, but let's see if you can pick it up. What distinguishes goal-based agents from simple reflex agents? They rely on immediate stimulus-response interactions. They act only based on pre-programmed rules without adaptation. They make decisions based on long-term objective rather than immediate conditions. They operate without requiring any sensor inputs. Okay, I'm waiting for everybody to poll in. We'll request everybody. This is just a quiz. It's not an assessment. Doesn't matter if you're wrong. I don't know who is answering what. It's anonymous. So just poll. You're not being evaluated based on this. It's just fun. All right. Let's see. Let's see some more results come in, and then we'll show you the results. Okay, 75% of you feel. Okay, can I get some more answers? I can only see 30 people have responded. Okay, let me give you the answer now. So, yep, most of you are correct. They make decisions based on long-term objectives rather than immediate conditions, right? Great. So that was some good quiz. Let's get back to where we were. What are the components of artificial intelligence? Now, this is an important part because most of it is what we don't use anymore. For example, expert system, but we need to know what it is because that's how AI has evolved. Neural networks, we do use it. Robotics is going to be a very, very important component in the field of surgery, and I know that we have many surgeons in this house, so this is going to be a big interest to you. Fuzzy logic is a very, very interesting algorithm to understand because not everything, the answer is yes and no. There's something in between, which is maybe. And fuzzy logic is the concept of maybe. And of course, the most powerful part of AI, natural language processing. Let's look at each of them one by one. Before we do that, another aspect of AI is to recognize speech and voice. What is spoken and who is speaking. This is important. If AI did not have this feature, then AI would not have worked. So speech and voice recognition, again, perceiving, reasoning, and learning makes it intelligent. So that's an important thing to remember. Now, expert system is the fundamental way by which AI was created. What does it mean? It means there was a human expert, there was a knowledge engineer, feeding information into a knowledge base, and then there was an inference engine, and then the end user was using based on whatever information was fed from the human expert through the knowledge engineer, capturing from the knowledge base, inferred through the inference engine, and the output going to the user. This was the component of the expert system. Expert system in AI had two types of, primarily they were of two types. One was rule-based reasoning and one was case-based reasoning. So rule-based reasoning means it's transfer of knowledge from an expert to the computer, following certain rules. Now you know how it can do deductive reasoning and inductive reasoning and the basic fundamentals. So following rules it can go. Case-based reasoning is it finds solution to new problems by adapting previously to good solutions to similar problems. This is something which you still do when you prompt. You give an example and it learns from that. So that's not case-based reasoning, but case-based reasoning has been conceptualized from there, right? So earlier days, you had the expert system with a rule-based reasoning and case-based reasoning, and also something called fuzzy logic. So if the decision is ambiguous, then comes the concept of fuzzy logic. So it's a very interesting concept to understand. We will discuss this. So it means that through an expert system, the knowledge from an expert can go to a non-expert user, either using rules or case-based examples. Expert systems were capable of advising, demonstrating, deriving a solution, diagnosing, explaining, but they were not capable of substituting human decision makers, possessing human capabilities, producing accurate output for inadequate knowledge base, or refining their own knowledge base. These functionaries come under the spectrum of autonomous AI, and that was not there in the earlier days in the field of conventional artificial intelligence. What do you mean by knowledge base? Now, this is important for medicine to understand, for medicine specialists to understand, for doctors to understand. The information that is widely accepted by the knowledge engineers and scholars in the subject expert or by the subject matter expertise, that is factual knowledge. And the other type of knowledge is heuristic knowledge, which is about practice, accurate judgment, one's ability to evaluate and guess. Remember, whatever we're doing in the field, in the practice of medicine is based on our knowledge, and that's factual knowledge or heuristic knowledge. And we will be feeding the AI ecosystem with either factual knowledge, with your guidelines, with your recommendations, with your textbooks, or with our own experience, which is the heuristic knowledge. What does the inference system exactly do? The inference system has two types of chain, forward chain and a backward chain. The forward chain is if 1 and 2 and 3 and 4 is a fact, then decision 1 and decision 2 and decision 4 is what happens next, right? Backward chain means why this happened. So if this decision is taken, then what was the fact that led to this decision? So again, the concept of inference engine comes from reasoning. So it looks at a forward reasoning or a backward reasoning, which they call it as a forward chaining or a backward chaining. What happens next and why this happened? This evolution has happened from expert systems to machine learning. So expert system is what we don't use anymore because it's the earlier days of AI. We shifted into pattern recognition, more advanced reasoning to machine learning, which is basically data-driven, more precision understanding, but using the same fundamentals of expert system and intelligent ecosystem with which it has evolved. Now, fuzzy logic is a very, very interesting method of reasoning, which resembles human reasoning because not everything will have the answer yes and no. There can be a certainly yes, there can be a possibly yes, there can be cannot say, maybe, there can be a possibly no, and there can be a certainly no. And this fuzzy logic was something which filled the gap between the rule-based reasoning. So where the answers are not yes and no, how do you solve that problem with an intelligent machine? It's with fuzzy logic. And that's why it became so useful. The concept of fuzzy logic is used in air conditioners. It means, again, a set of rules, it acts based on that set of rules. So if the temperature is cold or very cold and the target is warm, then the action for the agent is to heat. If the temperature is hot and the target is warm, then cool. If the temperature is warm and the target is warm, then there should not be any change. And that's the concept with which fuzzy logic works. Fuzzy logic in the expert system ecosystem works with a fuzzifier and a defuzzifier, and the inference engine plays the role in between. This whole concept of fuzzy logic is what started the insulin pump. These days, the modern insulin pumps runs on PID algorithms, proportional integral derivative algorithms, which is based on control theory. But control theory has evolved from the concept of fuzzy logic. So it means there is going to be a control, and there is any change in the blood sugar will make a change in the insulin dose. And that's how insulin pumps, the Medtronic's pump, came into evolution. And now, of course, we are looking at more intelligent pumps in today's world with machine learning algorithms, with prediction of hypoglycemia, etc. These type of pumps are now coming into the existence. But the fundamental of pumps was for the fuzzy logic algorithm, which was following the expert system of medicine in the evolution of AI. Natural language processing is a very, very important subject for doctors to know, because in the field of medicine, we are talking about medical jargons. And if we are not able to interact and communicate with the AI ecosystem with the right medical jargon in the right way, then we will have a lot of problems, which is called hallucinations. So what is NLP? It's a subfield of AI, which is focused on interactions between computers and human languages. And it combines a lot of linguistic intelligence, rule-based modeling with the statistical machine learning and the deep learning models. Natural language processing will be a separate module, which we will take in your upcoming sessions. And we will have a session dedicated to natural language processing, which we will discuss. You will discuss that with me, and we will have a lot of interaction and understanding how we can interact with the computer ecosystem. Just to introduce you all to the terms, there are different types of analysis which happens in natural language processing. For example, sentiment analysis. These are the different steps after data pre-processing. There is information retrieval, sentiment analysis, information extraction, and question answering which happens. So these are the different steps of natural language processing. Some of you might find this already a little too heavy today, but just bear with us. It's nothing big. It's something which you read, revise, and you'll get to know these terms, as we go along. Quickly, let me introduce you all to another new terminology after natural language processing, artificial neural networks. Now, this is very interesting. A computer system made up of simple, highly interconnecting processing elements, which processes information by their dynamic state response to external inputs. And remember, this happens at a very, very fast pace and simultaneously at the same time. And that was said by Dr. Robert Nielsen, who was the inventor of the first neurocomputer. And then came to the existence of artificial neural networks. Now, the idea of the artificial neural network is kind of based on the human brain and the human neurons. Just like, we have the synapses, we have the artificial neural networks connect with the nodes and the internodes. It's similar to the neural networks of our brain. So what you saw on the first slide is the biological neurons. What you see here is the artificial neurons. And the artificial neurons are composed of multiple nodes and internodes, and which imitate the biological neurons of the human brain. And they're connected by links, and they interact with each other. The output at which each node is called the activation or the node value. And they also have, each of these connects and links are associated with weights. And the entire artificial neural network is driven by nodes, internodes, weights, and their activation factor. And this is how the neural network of the artificial intelligence ecosystem looks like. So again, a quick similarities between our biological neural networks and the artificial neural networks. The soma is like the node, the dendrites are the inputs, the synapses are the weights or the internode connections. The axon is the output. So this is just mimicking the biological neural network. We have the artificial neural networks. But what are the differences? And this is what makes AI so powerful. Artificial neural networks is capable of storing the information in continuous memory locations simultaneously at a multifold manner. And it can grow massively parallel, and it can increase at a rapid, fast rate. It can learn very precisely. It can be more structured. It can reason, and it can evolve faster than the biological neural network. You have seen the picture of the biological neural network. This is how the neural network of the diagram of the artificial neural network looks like. Now, if you've been following papers or journals publishing papers on AI, this is a common diagram that you will see, and you will see something called an activation function. And this is the basic fundamentals of the neural networks and how it functions. It's got the input, it's got the output, the weights are there, the internodes are there, and it is driven by the activation function. There are three layers: the input layers, the hidden layers, and the output layers, all connected by weights and interconnections. The variable entry from one node to the other through the weights and interconnections goes on to give you the output finally as a classification, as a regression, as a prediction, and so on and so forth. And this is how the neural networks work in artificial intelligence ecosystem. What is robotics? Now, robotics is that branch of AI which is composed of electrical engineering, mechanical engineering. So it's the hardware part of the AI, that is robotics. And it includes electrical components. They contain also levels of computer programming. Now, when robotics combine with AI, it's a superpower. And that's, I think, what we are looking at in some of the fields of precision surgery. A quick look at the differences between AI programs and robots. Remember, AI programs operate in a computer simulated world. Robots, like with their robotic sensors and effectors, like an agent, will operate in a real physical world. The input to the AI program is in the form of symbols and rules. The inputs to a robot is analog signal in the form of speech waveform or images. And of course, it uses a lot of computer vision there as well. Robots will require special hardwares with sensors and effectors, and that's what robots are built of. So quickly looking at the various applications of artificial intelligence in medicine. So what I gave you was a brief overview and possibly a kind of a glimpse into the fundamentals of how AI has evolved and it has come in. And you will look at the application of AI in medicine in the field of healthcare, primarily working these 8 blocks. In personalized treatment with predictive analytics, using generative AI in virtual health assistants, in advanced medical imaging, in predictive analytics, in drug discovery, in treatment optimization, in optimizing surgeries using robotics, and enabling and enhancing remote AI monitoring with the help of telemedicine, also along with augmented and virtual reality. Let's move on to the next segment of trying to answer that why do we need to look at artificial intelligence in healthcare? This is very important for us to understand this. You all would know this gentleman, Geoffrey Hinton, who feels that we are moving into a period where for the first time, we may have things which are more intelligent than us. So we better tame it. But for that, we need to use it and learn it responsibly. Eric Topol, a person who's been an inspiration to me and many of you, I believe, with this textbook of his, Deep Medicine, says patient wants to be more autonomous than they are not so dependent. And we have the right tools to do that already, so why deny them that? And we are now moving into the real era of patient-centric medicine. And as medical professionals, we also have to adopt to this change that is happening with this intelligent AI ecosystem coming in. So the why, this is important. It elevates the performance of the clinician, and this is one of the most important why, because we have been practicing evidence-based medicine, and we are now evolving into the phase of standards of care of artificial intelligence. This is the second why. Development of drug with AlphaFold. If you have been following this space, you will see protein folding and unfolding by prediction has become such more easy, which means faster trials, faster approvals, cheaper drugs at a lesser period of time, at a lesser development period. And that is one of the beauty of using artificial intelligence. The traditional research paradigm will get disrupted when we use AI, because all we have been talking about is the tip of the iceberg that looks at the RCTs, the cohorts, the systematic meta-analysis, the systematic reviews. But we have been missing on the data, which has always been there from the patient side, the EMR data, the wearable technologies, the biosensors, the nutrition data, the labs data, the IOMT data. And that tells you a lot. If that can be run through federated server or federated learning, which is a term which we will discuss in the upcoming sessions, then a lot of models can be developed, which can be more intelligent and guide the clinician in a better way. And this change is happening very fast, from information to the knowledge gap, and this progress from evidence-based medicine to intelligence-based medicine as we go on. And the last why is very, very important. You all will acknowledge the fact that as doctors, as clinicians with years of experience behind us, our mind will most commonly think what our eyes sees the most. And sometimes that gets us into a cognitive bias. AI can be that neutralizing factor and take away that cognitive bias for us. So the important part is, from evidence-based medicine, a quick evolution of AI will take us into data-driven, intelligence-based medicine. And while we've been looking at only the tip of the iceberg, we will now be able to look at the entire iceberg as a whole in a data-driven, intelligent manner, with reasoning, with perception, and with continuous iterative learning happening along the pathway. So it will help us see what we have been missing, and that is the whole power that artificial intelligence brings you. Let's quickly go on to the last segment of the polls. And I will start the poll. Okay. This is a question on expert system. In the context of AI-driven expert system, what is the primary role of inference engine? To store medical guidelines and patient data, to generate new knowledge by applying rules to the stored information, to translate spoken language into structured text, to display user-friendly outputs to healthcare professionals. What's the purpose of inference engine in expert system of medicine? And I think most of you are getting it correct. I request everyone to quickly vote in so we can display the results, or you can see it already on the screen. Yeah, I can see most of you have got that correct. To generate new knowledge by applying rules to stored information. That's the purpose of the inference engine. Okay, the last one. Which of the following is a major application of AI in medical imaging? Now, this is a field which is rapidly evolving, and we have seen a lot of development happening in the field of radiology with deep learning images and neural networks. So what's the whole purpose of it? Replacing human radiologists entirely, improving the diagnostic accuracy through pattern recognition in the imaging data, eliminating the need of medical imaging altogether, automating all aspects of patient treatment without human oversight. So I think all of you would agree that the purpose is to improve diagnostic accuracy through pattern recognition and imaging data. But again, as we say, we have to make sure how much of automation we need to allow it in a responsible manner with the radiologist in the loop or the human in the loop. So yes, I believe you all got that correct, 34 people. Right, so I think we have come to the end of it. I will leave you all with this thought and flow that in the modern era, friends, we need to be bilingual. Your step into this course is the first step of becoming into this journey of becoming bilingual. We have to comprehend these technology terminologies as much as we understand the medical jargons. Thank you. I should stop sharing now, and I will let the admins take control back from me. So while you do that and give the control to Professor Pankaj for the next session, I will quickly go through all of your questions and I will try to answer them. Let me look at the chat box. Okay. Okay. So not much in the chat box. Isn't there a further definition of super intelligent? Well, not that I'm aware of, Dr. Molly. You could define and tell me what is super intelligence. I think we're still defining artificial general intelligence. So maybe soon we'll be able to define super intelligence too. But if you have a better way of defining it, put it down in the chat. Okay. This was the question from Dr. Molly. Isn't there a further definition of super intelligence? We'd love to discuss on this at the end of the lecture today, of the sessions today. Yeah. Okay. Right. So I think good. So if you all want to grab a cup of coffee, we can take a 5-minute break or a 2-minute break. If not, you're ready for the next one. I'll be happy to hand it back to the admin team.
So we give the control to.
Okay, admin.
Yeah. We give the control to.
Yes.
Okay.
Yeah. Yes.
Pankaj, it's your turn. Pankaj Jayagupta.
I hope he's there. I can see him online.
Yes, he's there.
Yeah.
Okay.